Welcome everyone. Again, this is Kerry O'Connor from IronCAD, and I also have RJ Saucier from Genesis Technologies. He is here to help present our webinar today for sheet metal design in IronCAD. And we're just going to go ahead and get rolling on this, and we'll do a few PowerPoint presentation here up front just to give you a little bit of an overview. So let me go ahead and get started. Just a little bit of background of IronCAD if some of you are new to IronCAD. We are a company that's been around since 2001. And we are based out of Atlanta, but we have history dating back to the early 90s for technology that's been in the design market space, primarily for the machinery design, that has a lot of patents on various things in our product that's really led the industry and grown through the years and has been adopted by other applications. And we continue to be innovative in this area and in this space to help basically lead into our mission, which is to develop the best 3D design and collaboration software tools that increase customer productivity. And above all, really, it is to help them achieve success in their fields. And we really base our mission and our beliefs off the fact that we believe that everybody can design better and faster using software that is modeled on how you interact in the physical world. And when you see our presentation today in sheet metal, you'll see what we mean by this is how everything is really working on 3D geometry that's interacted with anything that you're designing that you can reference and build upon that. It's really almost like a hands-on experience with IronCAD. And one other thing that we do like to highlight is we do have a lot of customers that are very satisfied with the way IronCAD as a company and as the product interacts with them. We really focus on this and really try to bring in everybody's input to new functionalities to the product and resolving any issues that are found. We really pride ourselves on that, and hopefully if you are an existing customer, you've experienced this. If not, we hope to have you on board to see this firsthand. So let's kind of get into this a little bit. So our sheet metal design webinar today is really to help show you these key factors, really starting off with how we design in sheet metal, which is a little bit different than everybody else in the industry, where we use catalogs and drag and drop to really expedite the design process. And you'll see that through RJ's presentation on how that really makes it fluid in the design process, along with the push and pull design handles that we have on our geometry to allow you to reference anything that's in the 3D design environment, to accurately snap to those objects, to build from those existing objects, just using the dynamic push and pull on geometry and even all of our tools. We also will be focused on how we do things that you might find standard in the sheet metal, which are like punches and forms, and we'll show you a little bit of that and how we've added some new technologies to those to make it a little bit easier to leverage things. Predefined sizes, for example. We'll give you some demonstrations on that. We'll also show you how to design from the flat. For example, if you have a 2D DXF that may be coming from a supplier or another customer or something that you can bring into the IronCAD and use that and build up a sheet metal design part from that 2D DXF. We'll also show some more of the advanced capabilities for miters and closed corners on the sheet metal and how they're fully associative. And we'll also show you a little bit about sheet metal lofts in IronCAD and how you can actually create loft geometry and unfold that for press brake manufacturing, if you wish, to have those type of bend lines, for example, in your lofts. And RJ will give you a good example of that in the demonstration. And the last thing we'll show is after you build all your sheet metal and creating your unfold flat patterns is how you take that into a drawing environment, how you can manufacture that quickly within IronCAD's product. And using our newest product, you'll see some of the new functionality for bulk drawing creations, which will make this process even faster. And just to give you a little bit of an idea of what our sheet metal is designed for, what type of customers, we are really focused on custom design sheet metal manufacturing companies or bespoke manufacturing products. And you can see a few examples here on the screen that have various components that are either customers of ours or examples of customers that are using us today for sheet metal design. So I don't want to take too much more of everybody's time for the boring slides. We'll go ahead and jump right into the presentation with RJ. So I'll let him go ahead and get started here, and I'll give him control. Let me change presenter. Hold on one second. Okay, RJ, you should have control.
All right, let me know when you see my screen.
You're good.
All right, well, welcome everybody. As Kerry said, my name is RJ Saucier. I have a extensive background in sheet metal and have been designing sheet metal and IronCAD for about 6 years now. So it was nice to be asked to do this, and hope I'll be able to answer some questions today. So what we're going to do is we're going to build this cabinet design today using some of the different features that Carrie mentioned in the presentation. So to start off with, what we're going to do is I'm going to go ahead and drag and drop out basically what I would consider 2 walls of a construction to represent where we would be mounting a cabinet. So a couple things to start off with. One thing I do want to talk about is a couple options real quick with the sheet metal as well as the stock table, how that works. You'll find under the sheet metal tab, we have several options. We won't get into all of them today. We'll just touch on a couple. One option that I do like is this option allows us to take the part properties for the flat from the folded part. So when we create a sheet metal part that has press brakes in it, we go ahead and populate the data. We go to unfold that part, it'll automatically transfer that information to the folded part. Another option that I like to use is, as far as when you're doing bends, we have options as far as controls for when you set the dimension of that bend, what it's from: flange, tangent, inner sharp, outer sharp. I typically design using outside dimensions, so I like to use the outer sharp, okay? Now, our stock table, you'll notice that my stock table will be different than the stock tables that are standard in the IronCAD download. It goes to show the flexibility of being able to create standard stock tables, sheet metal tables. And what I have here is a table that I developed that includes 304, 316 stainless, as well as multiple versions of different aluminum stock. All of these are customizable, and you can find those tables in this folder location, both the stock table and the tool table. The stock table is used for sheet metal. The tool table is used for the punches, and we'll talk a little bit more about that later as well. So,
one additional comment before we get started. If anybody has any questions, you can feel free to use the chat message to ask questions, and we'll have some people online that will answer those as we go through. And at the end, we'll follow up with an open question and answer area that we can discuss at the end. So
okay.
Go ahead, RJ.
Okay. All right. So one other thing that I want to start off with as well, if you have downloaded 2018 and started to use it, you'll notice a new heads-up display in IronCAD. When you click on a feature, a part, you'll see this pop-up floaty. It's about 50-50. Some users like to have the pop-up floaty right there where the mouse is. You'll notice that in my presentation that I like to keep mine up at the top of the window. So for users that want to use that option, I wanted to let you know that that is available to put that at the top of the scene if you'd like, or at the bottom of the scene. All right, so to get started, the first thing that we're going to talk about is we are going to talk about converting to sheet metal part. And this is handy if you have a solid and you want to create a sheet metal part from that. And what we're going to do is we're going to go ahead and create the mounting bracket for our cabinet assembly. So I'm going to simply click on our face, and you'll see that we have an option here for auto select connected faces. So in this example where I have the radius corners, it picks up that those faces are connected and does not require having to select all the faces. They're joined. So what we'll do is we'll go ahead, I'm going to change my stock. I'm going to select 11 gauge cold roll steel. My number of bends will be 1. I just want to have 1 press brake show up in my drawings, and we'll do an offset distance of 130 thousandths. So what you'll see now is that I've created my sheet metal part, right off of that wall. Now we don't want to go the full length of the wall. So what I'm going to do is, let's go ahead and first I'm going to give it some color, and then we'll go ahead and edit the cross section. Now, you'll notice when I do my demonstration, just in case anybody is curious, by default when you load IronCAD, you will notice that when you edit cross sections, sometimes it will rotate and flip around to a certain view. I like to kind of keep mine at the view that I set it, and if you are interested in that option is right here under the General tab, Enable Camera Look At, and that way when I edit my cross section, it stays in the position at the time I edit. All right, so what we're going to do now is we're going to shorten this. I'm going to go ahead and click this edge here, and we want to drop this 24 inches down from the top. I'll select the bottom now, and we'll make this 24 inches long. And now I have my first sheet metal part. We'll go ahead and put in our property information. We'll call this cabinet mounting bracket. Give it a part number and 11 gauge cold roll steel. Okay. The next thing that I want to talk about, which will lead into one of the new features in 2018, is what's called our front view definition. By default, when you create views in your 2D drawings, IronCAD has a standard view from the global orientation. However, it's very common to want a different view. Well, in 2018, to take advantage of creating multiple drawings at the same time, we can create what's called a front view definition. Basically, what this does is I select the front face of the view that I want in my front view. Once I select the face, it'll automatically toggle over to the direction I want, and then I can select the edge, and this will give me the direction of the view in my 2D view. You can also toggle this if you want to change the view. Just simply left clicking on that will toggle the view. This will be very important when we get to the end of the webinar and we talk about moving these over into the 2D environment. So I'll click finish. I'll go ahead and unfold my part. I'll right click to create my front view definition, select my face, select my view, finish, and unfold. And now what I have is my first part is now set for my 2D drawings. All right, so what we want to do now is we want to go ahead and we'll come over to our sheet metal and we want to start our cabinet. So I'll simply left click and hold my mouse button, drop into the scene. Let's go ahead and change some properties. I want to make this out of 16 gauge. And what I'm going to do is I'm going to select the option for bottom. Okay, what this does is by default, when you thicken a piece of sheet metal, the default reference point is the center line of that sheet metal. So if I keep the center line as my selection, I go from 16 gauge to 1/4 inch, the part will thicken uniformly top and bottom. However, since I'm using my backer plate for reference, I want my sheet metal to thicken from the bottom to stay associated with that plate. I'll select my 16 gauge, go ahead, we'll call this our cabinet, PPO2, 16 gauge, cold roll steel, and we'll click OK. Now what I'll do is we're going to go ahead and size our cabinet. So I will select our size box handle, and holding the control key down, you'll see now that both of the outside handles are highlighted. If I type in my dimension, you'll see that it sizes uniformly, and I will do that for both dimensions. And now we have the back of our cabinet. Okay, well, now it's time to add our bends. There's a couple things to talk about here. Within the sheet metal catalog, there are 3 different options for bends, and there's actually a secondary option for those same bends. Just to do a quick explanation, if I was to drop a bend onto the sheet metal, what you'll see is it adds the bend to the sheet metal as well as our stock. If I do an inside bend, what you'll see is that the dimension of my plate is held equally to the inside of the bend that I have put on. And as I mentioned earlier, outside bend is the one that I most commonly use. And you can see by holding the outside bend, if I have an outside dimension of 36 inches, by using an outside bend, I'll maintain that. Also, what you'll see is that those same options are available with stock. Now, let me explain real quick what this means. If I drop an outside bend with stock, you'll see that in our scene tree, we have our add stock and our bend are 2 separate features, as opposed to the early example, it's 1 feature. Where this is beneficial is if you want to make an adjustment to the cross section of a stock material, you can do that with that option, okay? My early days of IronCAD, I always use outside with stock. However, in recent years, IronCAD has made several enhancements to how it handles sheet metal. I find that the option with stock is not as necessary anymore, and probably 95% of the sheet metal design I do, I just use an outside bend. And you can see in our tree that we have just the one feature now. So what we'll do is we'll go ahead and size this. I'll left double click the handle. And this is where, mentioning earlier, you have the options of what you want for your reference point. I like the outside sharp, which is on by default. I'll type in 10 inches, okay? Finally, we'll add our lip. Go ahead and drop in another outside bend. And one thing to note too, if you're new to sheet metal and IronCAD, the edge that you pick is the direction of the bend that you get. So if I drag and drop an outside bend and I reference this lip, I get a bend up. If I go ahead and reference this lip here, I get a bend down, okay? So we'll go ahead and left double click again. We'll change this to 1 inch. We'll click OK. All right, so now we want to complete our cabinet. The way that we would do this is with our add miter feature. And what this will do is we'll take those two bends that we just created, make them uniform around the whole cabinet. So I'll go ahead and click the add miter feature. We want to select our bend shapes, so I'll go ahead and select my two bends. Then I'll move over to my straight edges. Now, when selecting straight edges, you do have the option of being able to select individual edges if that's your preference. In this case, where we want to select all three edges, I can simply select the face. IronCAD selects the edges for me. I click Finish. And what you'll find is that it gives us a nice wrap around the whole entire cabinet and nice closed corners as well, okay? So let's go ahead and let's give this some color as well. Select that, click OK. And of course, we want to go ahead, do our front view definition. I'll select that for the front. I'll zoom in, select that for my direction, finish. We'll zoom out and unfold our sheet metal part. Again, we'll go ahead, set our front view definition and finish. Okay, now what I want to do is I'm going to go ahead and build the door now. And since it's the same basic design as my cabinet, what I'm simply going to do is use that, and you'll see how nice it is inside of IronCAD to reuse current geometry. I'll simply right click. I'm going to position my triball center, hit my space bar so my triball is blue again, and I will right click, do a mirror, and copy. So let's go ahead and give this a new color so we know it's a different part. Under our properties, we'll go ahead and change this to our new part number. And then what you'll see is if I zoom in, see I may need to reselect the part. I'll zoom in and there are handles. There we go, there's our handles. I'll left double click. I'll change this to 1.25. And you can see that our sheet metal door is now resized accurately. And let's go ahead and give this some transparency so we can kind of see through what we're doing. And one thing that's really nice about the add miter feature is if I take and make an adjustment to the angle, you'll see that it stays associative. So if I edit this angle to, let's say, 70 degrees, what you'll see is that IronCAD will update automatically, and it will update the entire sheet metal part based off of that geometry, based off of that change. So the association is really nice and real easy to use. Okay, so the next thing that we want to do is we're going to talk a little bit about our sheet metal punches. For this example, I'm going to go ahead and install a lock into our cabinet door. To do this, I want to go ahead and use our double D for our lock, and I will zoom in, and what you'll see is with our sheet metal punches, you have options to change it different sizes. Now in this case, I don't know what size I'm actually getting when I toggle, so what I'm going to do is I'll right click, go to my tooling properties, and scrolling down, I want to go ahead and select my 3/4 by 5/8. I'm going to select OK. And I actually want my orientation to be 90 degrees, so I'm going to activate the tri-ball. And very quickly, I'm going to just grab this inside handle, snap to that face. It aligns with that face, and I get my 90-degree orientation that fast. So what I'm going to do now is I want to position that. So I'll edit all of my smart dimensions. We'll change this to 18 inches. We'll change this to 1.75 and click OK. Okay. What I've done is I have created a standard lock. I'm a cabinet manufacturer, and this is a standard lock that I use all the time. One of the nice features in IronCAD is we have what's called attachment points. So I'd like to demonstrate this during this because attachment points can be very helpful. So simply what I'm going to do is I'm going to select the IntelliShape for that D slot. I select my option for a new attachment point. Holding the Shift key down and selecting that radius, you'll see that I get my attachment point placed right in the center of my D slot. I'll right click. I'll go ahead and set my name. We'll change that to common. It's going to be a neutral attachment point. I'll select OK. And I do know, based off of the XY orientation, that I want to move that. I'll attach my tri-ball and simply rotate that 90 degrees. All right, now that I have my attachment point set, all I have to simply do now at this point is I can just drag my lock out, I can drop it in, and that lock is now associated with that D slot, okay? What's nice about it, once you have that set, is I can come into that slot. If I wanted to make a change, I can simply change that to 16 inches, and that lock will stay associated with the slot, okay? So getting into some more punch features, what we'll do now is we'll go ahead and add some more cutouts. We'll add some louvers to our cabinet. The first thing that I want to do is go ahead and drag and drop in a square cutout. Let's say we're going to install a fan. I'll simply right click under my tooling properties, and what you'll notice is I want a 4-inch cutout. Well, we don't have that cutout available in our list, so nice thing is I can just click the custom option, type in 4 inches, 0.125, click OK, and we now have our cutout. The association of the dimensions can be changed as well. What I mean by that is currently we are referencing the back based off of where we drop. If I want to change that to reference to the front, all I have to simply do is left click and hold, drag that over to the front, and I've changed my association to my front of my panel now. I can simply click that, change that to 5, we'll left double click that and change that to 6. So those associations can be moved from top to bottom or front to back if you want, okay? All right, so let's go ahead and add our louvers. We'll come back over to our catalog and we'll find our rounded louver. I'm actually going to go ahead and use this as a reference point and drop that in place. Here again, I want to reference the top. So I'm just going to simply drag this, move it to the top. I'm going to drag this, move it to the front. We need to rotate it, so I activate my tri-ball. Simply, again, left click the handle and hold on the axis that I want to rotate. I can snap to the face, and that fast I've rotated around 90 degrees. An excellent and very handy tool. So now what we're going to do is I'm going to resize, and this is a good example here too. If I go into my tooling properties, this is an example of one that I've added to our to the library, the text table that we have that we talked about earlier. It goes to show if you have a standard size punch that's not in the catalog, it's very easy to update. So once we have that done, there we go. And click the green dot for finish. We'll come over to our home. We want to go ahead and do a pattern feature. And in this case, I want to do an edge pattern. I'm going to go ahead and select my edge. We'll zoom out to see where we're at. I want to uncheck the option for a long edge. We'll change that to 1, 6, and finish. And let's see, it should update 18, 10. And that updated beautifully for us. Okay. So what we're going to do now is I want to use this cutout. We're going to go ahead and in our example for demonstrating a loft, we're going to create an exhaust transition. I want to reuse this same feature, so I'll activate the triball. I'm going to right click. Once I right click, I have my options to point. I'll pan around. Now, when I get to my point, if I left click, it's going to simply move, but I don't want to move that, so I'm going to right click and I'm going to select the option to copy here. I do want to reset my triball. I'll click OK. Once that's set, I just grab my handle and boom. I've reoriented in split time. And these dimensions here we don't need, so I'll go ahead and delete those. Okay. So we're well on our way to building our new cabinet. We've got a cabinet, we've got a door. And the next feature that I want to talk about under our sheet metal is I want to talk about adding closed corners. So what we're going to do is we're going to build a bracket, a mounting bracket. I'm going to left click and drag our stock on. And here again, we're going to go ahead and select our part properties. We're going to select our new stock. I'm sorry, we need to select bottom, select new stock. We're going to do 3/16 material. Go in here, mounting bracket 4. This was 3/16 inch, a 36. Click OK. And now what we'll do is we will go ahead and resize this. So I'm going to select down to the IntelliShape, and here's another unique feature inside of IronCAD. We have 2 sets of handles on our IntelliShapes. We have what's called our size box handle, and if I select this option or using the tab key, we get our profile handles. The nice thing about the profile handles is we can use those to reference any geometry in the scene, which you'll see in a moment. But what I want to show you about the size box handles is that these are basically the handles for the bounding box. So just real quick, if I come in, if I was to change the geometry on that, what you would see is the outline for the overall bounding box of the sheet metal part, okay? In this case, we won't need to do any of that. So I'll select down, I'll tab over, I'll grab this handle here, snap to the back face, and then I'll right click this handle here, edit distance from point. We'll select this point here. I'll type in 3 inches, and then what I can do is tab back over for my size box, type in 8 inches, type in 3 inches. Okay. Now we'll go ahead and add our outside bend. I'll left double click that handle, change that to 2 inches. And we'll go ahead and add a couple bends on each side. That will serve to be a reinforcement for us. And this is where our closed corner comes in handy. So as you can see, we definitely don't have the kind of corner that we're looking for. So I can simply click my add closed, select the back of my plate. You'll see that these 2 edges highlighted red and blue to be mated. This has not yet, so I can just select this. You'll see that those are now highlighted to be mated, and we'll click finish. All right, let's go ahead and give this some cosmetic look to it. We'll go ahead and put some chamfers on this. What I want to do is my distance to distance. Those are both selected. So my first distance, I'll do 2. This selection, I'll do 1. And because these are actually facing opposite directions, what I want to do now is I want to select this option here and toggle that value so that they're both the same. I click finish, and now all we have left to do is add our mounting holes. So I'll go ahead, drop my cylinder, my H hole. We'll do a 7/16 slot for a 3/8 bolt, activate the tri-ball. I'm going to right click, I'm going to link here. I want to do 2.5 inches. I do not want to reset the tri-ball, so I can delete my reference hole, repeat in the reverse direction, click OK. Then all I have to do is escape, delete, and there is our mounting bracket. Okay, so once again, we want to do our front view definition. I don't believe I did our cabinet yet, so let's go ahead and unfold our cabinet door. And then we'll set up our front view definition for this. Finish that. Fold that back up. Select our mounting bracket, front view definition. And we'll toggle that over so it's the other way. Finish that. We'll unfold that. In this case, I know that when I come into my view on my drawing, this is the view that I want. So I'll select my face, and we're done that quickly. And we'll fold that part up there. Okay. So the next feature that I want to talk about a little bit is our sketch bend. There are times where you may have a sheet metal part and you actually want to draw a sketch to be able to fold up around the sketch. So for the example of our cabinet, we're going to build a couple of clamping rails, okay? We call our supplier, we asked for some 3D models. They didn't have any, but he did happen to have a flat layout for the part. So what I'll do is I'm going to drag and drop my stock in. Part properties. Let's go ahead and select, we'll do 20 gauge on this. This is our U bracket, and this is a purchased part. We won't need to do a drawing on this one. Let's say McMaster Car is the company that we got it from. So we'll put that in. And we'll edit our cross section, delete this. So what I'm going to do now is I'm going to go ahead and import the geometry that I need. So what you'll see is this is our mounting rail geometry. I don't need any of those layers there. Click OK. We want to take it from our model. Click OK. Done importing, and finish. So very quick to import. So now we want to put our bends on here. So I'm going to select the option to sketch bend. I'm going to select of my sketch bending. I'm going to activate the tri-ball to reposition point to point because I know my break lines. My break lines are already set in there. Go ahead and import. And we don't need any of those layers. All right, so we'll click OK. And now what we're doing is importing our bend lines. Click OK. Done importing. We'll finish that. And once we finish the import of the geometry, it'll automatically go into our sketch bend. So the first thing that we have to do is we have to tell it what is our fixed geometry. What do I want to be my flat surface? This is going to be the top of my U channel. So that's the one I select. You'll see that it automatically toggles over to the bend lines. I'll start selecting my bend lines. And then what I'm going to do is I need to change, 2 of them will be going down, 2 of them will be going up. So we'll flip the bend direction of the other 2, click finish. And I actually need to go ahead and flip that around. So we'll just do a mirror move, pull that out. Using the tri-ball, I'll edit distance from point, 8 inches. And we'll do a link copy so that we have a couple of mounting brackets for anything that we would want to put inside of the assembly. So the sketch bend tool is very handy for when somebody sends you a flat pattern, but they don't send you any other information. If you want to do an oddball, a bend of some sort where you just want to put a line across a flat pattern, a flat part, you can do that very easily. Okay. So finally, the last thing that we want to talk about as far as developing the sheet metal is we want to talk about creating a sheet metal loft. Okay. The loft tool is very powerful. I've had real good luck. The Create Loft was one that I used. We did a project for the New World Trade Center through IronCAD, some elliptical bollard covers, and the tool just performed absolutely flawlessly. So what I want to do now is we're going to go ahead and create a 2D shape or 2D sketch. I'll select any place on the face, click finish, and I want to go ahead and reposition that to midpoint, point to point. And what we'll do is we're just going to go ahead and very quickly project this face, delete the outside. And in order for the loft to work, you do have to have a seam. So what I'm going to do is just come in very quickly, create a small seam in there. We'll finish that. Okay, we'll activate the tri-ball. We'll make a copy of this, say 4 inches down. And what we want to do is go ahead and edit that now. Left double clicking will highlight all associated lines I can delete very quickly. The center radius, we'll pick our center, right click, 1.75. And here again, we'll have to have a split for our seam. So we'll zoom in so we can get a nice small split there. Delete and finish. So now that we have our 2 profiles, we can go ahead and create a loft. I'll simply hide this real quick. We'll come up to our sheet metal. We'll create a loft. And the first thing we want to do is select our profiles. And you can see that we have a preview of our loft now. I like to use the outside profile location, and a nice feature put in, I believe last year in 2017, is now you have the option for press bend. You can tell how many bends you want and actually get press bends for fabrication. So we'll click finish. We'll go ahead and unfold our sheet metal part. We'll get a view orientation, set our front view definition, and finish that. Okay. And actually, let's go ahead and give this our part number. Sheet metal part, this is going to be our transition. And this will be 16 gauge cold roll steel. Okay. There's our cabinet. So we have covered the features of our bends, changing and using different size stock materials, different punch features, as well as up on our ribbon bar, we've talked about lofts, sketch bends, how to use the add closed and add miter. So what I'd like to do now is show you our new feature in 2018 about our bulk creation tool. So you saw as I went through developing each of the parts, I put a front view definition on those parts. What this is for the new wizard that we've incorporated for creating bulk drawings. That happened because you do have to save to continue. So we'll just change this to cabinet 2. Cabinet 2. Okay. Now once that's saved, we can go into our bulk creation tool. And the way the bulk creation tool works is it works off of predefined templates. And you'll see in a moment the advantage of having these predefined templates, especially when working with sheet metal components. So what I'll do is I need to create a new drawing. And for my first sheet, I typically like to use a bill of materials because it's advantageous for using text strings. You can pull quantity information automatically off of those bill of materials. So what I'll do now is I'll select my different parts. There's our part PPO1. I have this 1 to 10 scale set up by default. 2, 3, 4. Now 4 is a smaller part, so I'll come in and change that template to 1 to 4. Same thing with PPO5. I like to go ahead and make that a 1 to 4 also. And double click that, and we'll click OK. So what happens now, based off of the templates I selected, IronCAD will go through and automatically create all of the drawings for me based off of those templates. Okay, so it's a very powerful tool, especially if you have sheet metal projects where you have 30, 40, 50 sheet metal drawings. As you're going along, you set those front view definitions, and IronCAD will create all those drawings. Now with the cone is a little bit different because it has a tapered feature to it. So what I want to do here is I'll edit the view orientation. I can basically reset that from scene, update, and now I can get the desired view that I'm looking for. Easy to change in this example here. I can simply come in, I can select those 2 views, change my custom view scale to 15, select OK, and now I have my updated views. So when we talk about the templates, what's important is that when you're creating sheet metal drawings, in this example for laser cutting, there's several things that have to be considered. One is that you have to have something that the laser nesting software can read. What I've done inside of my template is I've already created everything that has a front view definition. Everything that has a front view definition, let me change that real quick, is automatically set to use this view scale for my export, as well as being on a laser layer. So now that I've created all these drawings, I've created them with all my templates, it's extremely fast to come in and export to a DXF. We'll do test, save that. I want to do all sheets in the drawing, and I'm using that selected default view from each scale. The reason this is important is that you notice that we have some small parts, we have some large parts. Well, it's very important for outputting that all of those parts are at a 1-to-1 scale so that they're cut properly. Well, by having all of this information in the template, it's very quick and very fast to go from a 3D model, bulk creation tool, export, in 6 or 7 mouse clicks, you can go from a model to a set of drawings that can be imported into a laser. So that's it, Carrie. I think I've covered everything.
Okay, well, thank you, RJ. Very good on the demonstration there. And let me take control back here. Well, actually, let's leave your screen up just in case there's any questions or whatnot on there. So I just wanted to wrap up here at this point. So I really appreciate everybody joining us today to watch this demonstration on sheet metal design, and hopefully you learned a few new techniques on how IronCAD's capabilities with the catalog drag and drop, the handles, referencing existing geometry to snap and associate your sheet metal parts, and also creating from EXF geometry or lofted sheet metal. I got a pretty good demonstration of that today, and really highlighted at the end here is how fast to actually take your 3D geometry into a 2D production drawing with basically a click of a button. So at this point, I would like to go ahead and open up to the questions, and I'll read a few of these. And just one general question someone had here is, they said, "Wow, what's the screen resolution that you're running there, RJ?" Because they really liked what they're seeing there. Do you know what your display is?
No, I'm not sure. I think it's the 1280 resolution.
1280. Okay, that's good. It looked really good on our side. So watching the configuration process. Just a few other. Let some people ask some questions here as we go through to this. Most of them were fairly simple. So the very first part that you had in your scene that RJ dropped it out was basically just to refer to the wall as our base point. So he used that as a reference, then built from that a basic sheet metal part. And he did highlight a lot of times inside of that front view definition. And just keep in mind, you don't have to, if you don't use the bulk creation tool all the time, you don't necessarily have to use that front view direction, but it is quite handy, especially when you get into different orientations of your model. If your models are rotated in 3D space and weird orientations, that front view definition really eliminates any issues when you go and create your drawings. You can quickly pick your part, it'll be oriented right, and you can create your view layout. So it is a very handy tool, but not always necessary to use if you don't like. Some other things in there he did mention in the beginning, that we do have these tool tables and stock tables that are fully customizable. As you saw, he had customized both those tables, one for the stock for his own usage, which a lot of our customers do. Also for different regions, if you're a metric user versus an English-based system, you can also have two different stock tables for those different regions to be used, and can be easily shared with other customers or other users in your organization. We also have a question here is, how do you set dimensions for lines on sketch bins if you want to put your own bins and not import them from other files? So when you're in the sketch bin tool, it's basically you're fully in a sketch mode. So you start with a sketch, you can draw any lines that you want and use the standard 2D dimension tools to place those curves wherever you like in the sketch. So you can do as RJ did, import geometry, and they kind of come in place where the outer boundary geometry was, or you can he could have just simply drew the line, put a dimension to refer to that existing geometry, and give it the offset, if you will. So very easy the sketch to do that.
Yeah, I basically, when I did that, I used the import function just for the ease of time for keeping the webinar shorter. But anything that you can imagine doing in a 2D as far as drawing the geometry that you would like, there's no difference. Again, the import was just for time savings.
And as RJ mentioned, the sketch bin is really handy for those arbitrary corners that you have. In some cases, you want to fold a corner of a sheet metal up. That tool makes it really easy versus trying to cut the stock at a particular angle and then dropping a bend on there. It doesn't quite give you that on the unfold the correct corner result. So sketch bin is very handy in those conditions as well. Can also be used to create very complex bent geometry. Think of like a spiral. You could actually use lines at locations to create a spiral sheet metal part. Very interesting. RJ, just a question for you for lofted sheet metal. So do you typically use the press bin versus the standard result for the loft? Is that your normal process?
Yeah, now that we have that feature, I do use the press bends because basically everything I develop has to be manufactured, and you are able to dimension to the press bend lines so that a fabricator can basically lay out. If it's not etched, they can use that drawing to lay out where those lines are and be able to press break it. So I do use the press bend function a lot now.
And then on the drawing, you have options to display what is shown on those bend lines, correct?
That's correct.
So it can show your bend radius, the angles, and
yeah, the angles are critical, not so much the radius, but yeah, the information that you need you have all that flexibility.
Okay, thank you. All right. Well, I think that's kind of wraps up all the questions that I've seen so far. And if anybody has any other questions, feel free to give us a shout out either on our support@ironcad.com email address, or you can also find us on social media at any of the normal ones, Facebook, Twitter. You can reach out to us that way, and we can also answer questions in that form as well. So we really appreciate everyone attending today, and really appreciate RJ for all your time and presentation. And if you had any other final words, RJ, I'll let you have the last word, and we'll wrap it up.
Nope, I'm good. I just appreciate everybody's time, and I'm available as well if there's any questions about anything that you saw either in the features or the demo itself.
Alrighty, well, we appreciate RJ, and we look forward to hearing some feedback from all of our customers, and we'll follow up with some other information here shortly. Thank you, everyone. Have
Thank
a
you,
great day.
everybody.